into systems that are making use of database connectivity and how we can build, and number 6, some fairly complex systems with them. And then we'll wrap it up with just a discussion of licensing and system requirements. So the team that we have today, April Leverrier is our digital marketing specialist. Myself, I'm a senior applications engineer, and then Joanne Akbach is also a senior applications engineer. And she's going to be handling a lot of the question and answers that you guys might have during the presentation today. All right, so let's begin with the Data Logger plugin. So first, what is Data Logger? Well, for KEPServer, it's a plugin that will allow data to be logged from any driver within KEPServer EX. So the plugin is tremendously easy to configure, and the compatibility is with most ODBC compliant databases. So SQL, Oracle, Postgres, Access, Sybase, the big ones. So Data Logger as a plugin to KEPServer is tightly integrated with the core data server. So this means that you have KEPServer reliability, you have high performance, and you also have the typical easy setup that you get with KEPServer. We got some key features of Data Logger just to review really quickly. We can prevent data loss through a store and forward mechanism where we store records locally in the event connection to a database is dropped. We have a variety of triggering conditions that can cause the records to be inserted. We support batch identifiers, so we can map recipe batch numbers and that kind of thing whenever a log group is triggered. And then finally, we don't have any tag count limits, so there's no artificial limit imposed on you to the size that you can grow a Data Logger project. So a couple of different uses for Data Logger. Some of our customers might be logging process data from PLCs and programmable logic controllers and PACs and RTUs, DCSs, and high-speed manufacturing directly to databases within manufacturing execution systems. Others might be logging live measurement data from sensors like pressure and temperature and flow and those kind of things used in downstream, midstream, and upstream oil and gas production. Others might be sampling environmental data and logging that to databases to keep track of environmental measurements over time. And others might be logging data directly from barcode scanners or RFID controllers or other kinds of sensors used in batch processing. So I'm going to jump out of the presentation just for a minute and actually demonstrate Data Logger. And I'm going to do this kind of presentation and then demonstration continually throughout the presentation. So right now I'm going to exit the PowerPoint and I'll bring up KEPServer. So I've just got a blank instance of KEPServer. There's no project running. My runtime is on and it's activated. So I'm going to add a channel just with a simple simulator driver to simulate some data. And I'll choose the simulator driver to do that. And I'm going to move through some of these slides fast. We have a lot of ground to cover today, so the webinar will be recorded. And if you miss anything, you can certainly, within 24 hours, we'll have the recording up, and you can certainly reference that. So the tag that I'm going to create to simulate data is called a ramping tag. And I do this through the simulator driver as a specific address syntax. So the syntax for this is the word ramp, and then a speed, 50 milliseconds, and then a low limit, which is 0, a high limit, I'm going to say 10,000, and then an increment. I'm going to increment the ramp by 1. So go ahead and click Apply. And just so you can see the ramping value, I'll go ahead and launch Quick Client. And you can see here that I'm ramping quite fast. Every 50 milliseconds, I'll see a new data change event. So from there, I'll jump into Data Logger, click to add a new log group. I've already configured a DSN for the purpose of this webinar to save a little bit of time. DSN creation is something we've covered a couple different times in previous videos, so you can reference our YouTube channel for more information on that. I'm going to increase the update rate for this log group because my data is changing every 50 milliseconds. I need to read it at least twice as fast as it's changing in order to be guaranteed that I don't miss change events. I'm not going to enable batch identification or store and forward for this example. And then from here, I'm going to add the item to my log group and my data map. Go down to the simulator driver and choose my ramping tag. And then from there, I'm going to scroll down, and I want to create a new table in this database of mine. I'm just going to name it ramping. And I'm going to leave the table format as narrow. And then lastly, I want to define a trigger that simply logs on the data change event of that tag. So any data change event of any item in this log group will get inserted as a new record into the database. So from there, I'm ready to go. So I'm just going to click the Apply button, and then I'll have some confirmation messages down below. And then I've got my handy-dandy SQL Management Studio up and running. Just refresh my list of tables so I can see that new table that I created. And then I'll just issue a simple query to select the top 1,000 rows. And there we go. There are all my data change events. So that's Data Logger. Pretty simple and quick to configure, and there's no tag count limit, so we don't impose any artificial limitations on you. I'll just erase that to clean up the project for next time. Okay, so I'm going to jump back into the presentation. All right, so poll question number 2. We'd like to know if the folks out there are currently using KEPServer EX. So I'm going to go ahead and issue the next poll. And we'll give you about a minute or so to answer this question. Okay, we'll leave the poll open for another 15 seconds or so. All right, so I'm going to close the poll, and then I'll just share the results. So about a large majority of the people are the attendees are using KEPServer. A few aren't, and a few aren't sure. So we'll just go ahead and move on, and we'll talk about the Advanced Simulator next. So just like Data Logger, the Advanced Simulator is a very easy to configure driver for KEPServer, and it's interesting what it does. It simulates live data by traversing records in a database table at a rate set by the user. So it can do a lot of different, it has a lot of different features and functionality depending on the context in which you use it. But the general idea is that it acts as a single point of access to multiple data sources via ODBC. So the driver itself can support ODBC compliant databases and CSV files and Excel files and replaying records within those or data within those at a fixed rate. The rate that it replays those records is configurable by the user. And then when the driver reaches the end of the sheet or the end of the database table, you can configure what it does. It can stop or it can move back to the top and begin replaying again. And then we also have a control tag that will allow you to move the driver to a specific record number, so you could tie that to a client and have more control over the record that's being displayed. So a couple different example uses of this. This would be quite useful in a situation where you have a really ultra high speed data logger, like an embedded industrial device that's logging at, say, 5 millisecond intervals or even less, that is creating buckets of data in CSV files or Excel spreadsheets. One way to get that data into higher level business systems is perhaps to use the Advanced Simulator to replay that data at a slower rate so it can be better consumed and more reliably consumed by the higher level business system. And maybe that business system's doing trending and analysis or just collecting data for historical record keeping. We have other customers using the Advanced Simulator in test environments where they produce a data set, a test data set inside of CSVs or database tables, and then they have KEPServer replay that data to simulate live process situations, and a lot of the times it might be tied to alarm situations or stress tests and that kind of thing. Another simple way to use it is just to load data generated from legacy automation systems into OPC-based systems like SCADAs, historians, and HMIs. So we'll go ahead and demonstrate the advanced simulator now. I'll go ahead and just bring up KEPServer, and I'll add a new channel to my project. I'm just going to name this channel Advanced Simulator. I'll just select the Advanced Simulator from my list of drivers. And now I will choose the data source that I want to use, the DSN. And again, I created a DSN ahead of time for this webinar. So this is going to route me to my database that's managed here. And what I'm going to do is read back the oscillations table at a much slower rate than it actually, the system actually captured the harmonic oscillations that were gathered here. So I'll finish out the channel creation. That'll create my device. And I need to select my database column, and or my database table, and that's named oscillations. And then from there, I set the record selection interval. So I'm going to say I want this every 1,000 milliseconds. And then go ahead and click Finish. So now I've had a set of tags generated automatically for me. There's the move to tag that I referenced earlier. And here are all the columns in my database table. And I've got my, my numeric ID, my quality, timestamp, and value from the data logger in KEPServer that populated that database table. So now I'll just launch Quick Client. And I'll go into my advanced simulator device. And then you can see here that I'm slowly, at every 1 second, replaying the records inside of this database table. And so that could be much more easily captured or ingested by, say, an OPC-based SCADA system or an HMI than if it tried to read natively all that data streaming back so fast. So that's the advanced simulator. I'm going to go ahead and close Quick Client and move back to KEPServer and then move on to the presentation. Okay, so we have another poll question here. So how is process data stored in your environment? And I'll go ahead and launch the poll right now. And again, we'll give about a minute to answer this question. Looks like we've got about 90% of people voted, so I'll leave the poll open for another few seconds. Thanks, everybody, for answering. All right, great. So I'll go ahead and share the results with everyone. So most folks have another type of data logger that streams data directly to databases, but a handful of people are using an OPC connection from their MES. Some have PLCs that log data directly to databases, and then some are using KEPServer. And then, of course, some aren't sure, the questions don't fall into what they're doing. So anyway, we'll move back to the presentation. So now we'll talk about the ODBC client driver. And so again, with the advanced simulator and data logger, the driver, the ODBC client provides multiple methods of access for clients connected to KEPServer and other devices connected to KEPServer to database tables within ODBC compliant databases. So the goal of the ODBC client, the philosophy that we adopted when we set out to design it really was to make it possible for any client connected to KEPServer, that could be a device as well, to read database records and query data sets and then execute functions, which are otherwise known as stored procedures. So really brokering that communication between OPC and DDE and SweetLink and maybe device protocols to database languages. So some of the key features of the ODBC client driver are that it supports a variety of access methods, including tables of fixed size and dynamic size, along with user-defined queries. And we can also attach to and then execute stored procedures. And Oracle, I think, calls these functions. So we can, within the driver, we generate tags automatically based on the selected table and access method. So you don't have to do a lot of thinking in terms of how to address those records in the database. And then we can support access to hundreds of database tables within a single instance of KEP-Server, so you could grow the system quite large. So there are 4 types of access methods, and I'm going to actually demonstrate each type of access method for you in just a couple of seconds. But for now, we'll go through each one. So first we have a fixed table, and we're going to use a fixed table to access a database table where the record count is not changing, static. There's also the concept of accessing a dynamic table where the number of records are changing. And then we also have the ability to issue queries. So when certain data sets must be intelligently selected, we can have you design a query within our driver that will solicit exactly that data. And then stored procedures, so if end users would have, the need of extended functionality like inserting a record at a certain point or exchanging some inputs for a series of outputs, that's what a stored procedure might be used for. So example uses of each access type. So a fixed table, an HMI might be used to view a schedule of product model types and production line assignments. So I've developed a little demonstration for that. So let's look at that. So first I've got my master schedule here in my database. Very simple little master schedule. It just has the PLC product type. Let's get access to that from an OPC client. So within my same instance of KEP-Server, I'll just go ahead and build a new driver instance and call it the ODBC client. I'll choose the ODBC client driver. And then just like the event simulator, this driver uses ODBC to connect to databases, which means we'll work through the same DSN. And then I'll create my device. And the device for this driver represents a connection to an individual database table as well as an access method. So I'll go ahead and move through a couple of these here. And now I'll select my access method. Note I can select multiple, but I want to represent a fixed table. And then I have to select the table that I want. So that's my master schedule. I'll go ahead and select next, and I can import specific columns, and then I can set the number of records to import. I only have 2 records in this table, so I'm just going to leave the max setting to 2. And then I specify the rate at which I run or solicit new data sets from this table. And then I'll finish it out. You notice that we attempted to generate tags, and we completed successfully, and those tags are now stored below the device object. So by default, KEP-Server will store an individual column within an individual tag group, but you could easily reorganize these tags to be in a single group or reorganize them whatever way you want for better context. So I'll go ahead and launch Quick Client, and then I'll go to my ODBC channel, and you can see these records here. So batch ID 5 and 6 are records 1 and 2. PLC IDs line 5 and 6 are records again 1 and 2, and then product type for record 1 is cabinet, and for record 2 is countertop. So if I wanted to make better sense of this data, I might create one tag group below the device per PLC line, and then add the individual items within that line there to represent that over the HMI. But either way, you can see that we're pulling back this data. We have a fixed number of tags that we can use to access those records. So I'll go ahead and close Quick Client and then move back to the presentation. And again, I realize that I'm moving a little bit fast, but the webinar is going to be recorded. And so if you feel like you've missed something, you can certainly go back and rewatch. We just have a lot of content to move through, and I want to make sure that I don't take up too much of your time. So the second common use of the ODBC client is to use a dynamic table where the number of records in a given database table are changing. So we have to reorganize the way that we approach accessing that data to take into account the fact that there aren't a fixed number of records. So we can't just generate a fixed number of tags that are exactly analogous to the records in your database. So I'll demonstrate how the driver does this, and one common use might be allowing an operator to use an operator control panel to cycle through manually a series of recipes that are sourced from a database table within a manufacturing execution system. So I'll demonstrate that. I have a very simple recipes a database table right here. I can show you its contents. A simple recipe string with a recipe ID and then a batch ID. So those recipes, let's just imagine that there are continually new recipes added to that section of the MES's data table. And what we would want to do is give an operator the ability to look at every recipe the instant it's added to the database table. So to do that, I'll just add a new channel in my project. Again, this is the ODBC client, so I'll just identify it. And then from here, I just need to choose the proper driver and select my DSN. And then here, I'm going to name this dynamic table so I can have an easier time finding the tags once I attach a client. And here, I'll just select the table access method of dynamic table, and then I'll select my recipes table from my database. And then from there, I'll go ahead and finish the device creation. And then notice the set of tags that we've produced. These are control tags: move first, last, display the current record, move to a specific record, move next, move previous. And then we have tags that are based on the column headers. So what we're doing, if I launch Quick Client to show you, is giving the end user the ability to cycle through manually the data that's displayed in each field in each column. So if I wanted to move to the next record here, all I would have to do is issue a write command to the move next tag. So you can see that once I do this, the batch ID should change, the recipe ID should change, and the recipe string should change. So there we go. The batch ID is now 2. Chair model is 2, and then there's a new recipe string. So I'll do this one more time. I only have 3 records. There we go. But the last record is a blank record, which is why you see number 4. But now if I wanted to go back and look at that number 3, the batch ID number 3, I can move back, display batch ID number 3. Or if I wanted to move to a specific table, I'm sorry, move to a specific record, I can do that as well. Anyway, so that's the ODBC client driver. I'm going to jump back into the presentation to talk about the second to last table access method. So the second to last is a query, and this might be used to continually monitor the current part in production in a given production line. So what we'll do is solicit the very latest record that was added to a given database table with a particular query. So in order to do that, I'll just go ahead and add a new channel to my project. Again, ODBC client. And I'll select the ODBC client driver. Again, I'll select my DSN. And I'll finish channel creation, and then I'll add a new device. I'll name this query, just to remind myself what device this is. And then from there, I'll select the query access method. And this query I've actually pre-written, and I have it stored right here. This query will, again, just select the last available record in a database table. So I'll go ahead and validate that. Validate's OK. I'll go ahead and select next. I'm not going to define a trigger column. I'm also not going to go over this in too much detail. If you're interested in what a trigger column does, you can reference our help file, or you can certainly email us, and we can have a discussion about it. Great. So you see that I've just generated tags based on this query. So what these tags are is an ID field that'll tell me, okay, is this the first, second, or third record? And then I've got the second 2 columns represented. I've got a part number and I've got a serial number. So notice in my database that the last schedule the last record in products produced is 1, 2, 3, 4, 7, and ID number 3. So if I've written my query correctly, I should get that data set back when I reference these tags with Quick Client. So I'll go ahead and launch Quick Client, look at my query, and then look at the data that's returned from each column. So I've got my correct ID, number 3. I've got my part number, 12347. And I've got my serial number, 68892. And the design of this query is quite simple. It just selects anything from this table, which lines up right here. I've got this query that lines up with this table where the ID field is equal to the maximum ID from this table. So that's how I'm getting the latest record. I'm referencing the ID field and using a comparison that'll say, is this integer value higher or greater than every other integer value in this record or in this database column? So that is query. So the last access method is stored procedure. So a stored procedure might, allow a packaging manager to use an operator control panel to input an invoice number, let's say, and then return a series of related parts and quantities for the specific build of materials. So I've gone ahead and I've created a stored procedure called get build of materials, or get BOM, right here. Again, it's just a really simple little stored procedure. It has these variables and uses this method to access the data and populate those variables. We don't need any return value. We just, once you've assigned values to these variables, and as long as they're marked as output, we'll be able to see them inside of KEPServer. So to do this, I'm just going to add a new device below one of my channels, and I'm going to name this stored procedure. And from this access method, I want to choose stored procedure. And then I need to choose my stored procedure. So there it is, get BOM. And I'll go ahead and select next and finish. And then from there, you can see that we have a number of tags generated. We have an input where I need to input an invoice number. And we have a series of outputs that will output the data from the fields within the records that I'm sourcing. And then I have an execute tag that will actually tell us to go ahead and execute the stored procedure. So what I do to use this is input, I give an invoice number. So let's just go with invoice number 1. And we haven't done anything yet. We haven't executed the stored procedure. So in order to execute the procedure, I need to write any value to the execute bit. So go ahead and execute the stored procedure. And lo and behold, I've got my countertop type is granite. The quantity of countertops is 3, and then the wood type is oak. So there we go. I was able to source the build of materials for invoice number 1. If I wanted to choose invoice number 2, I could just type 2 into the input, and then again execute the stored procedure. And I've got laminate and pine, and then maybe the last invoice number is 3, and let's see what 3 returns. Cement and composite. Okay. Great. So that's referencing a stored procedure. Again, you might use that in a packaging environment where you need to input, say, an invoice number that you've received from the MES, and then from the part system or the work system, ingest the materials that should be packaged. So great. I'll jump back into the presentation, and that rounds out our discussion of the ODBC client. So I wanted to ask another poll question at this point. So how automated is your process control systems database interaction? So I'll go ahead and launch this poll now. We'll give it about 1 minute. Okay, we've got about 78% of folks voted in. Poll's open for another 20 seconds or so. Okay, so about 90% of folks voted, so I'm going to go ahead and close the poll at this point and share the results. We've got about 30% of folks fully automating their database interaction through PLC and software logic. And that's sort of what I expected. I mean, blended environments are much more common. A lot of folks, though, are also using manual database interactions, and maybe there's an opportunity to automate some of that for better efficiency. Maybe not. Some folks are doing PLC logic automation only, and then some folks aren't sure. So thanks to everybody for voting. That's really interesting. Great. So now we'll jump back into the presentation. So at this point, we're going to add advanced tags into the equation, and we can show you what the power of advanced tags can do when interacting with databases. So as a reminder, advanced tags, just like Data Logger, is a plugin for KEPServer, and what it does is extend the functionality of the core data server so that it can conduct logic operations and math operations and derive new kinds of data. So all of this happens automatically, and all of this within a single instance of KEPServer. We don't need multiple processes or multiple applications to do this. And there are 7 different types of advanced tags. The advanced tags that we'll be concentrating on today are primarily link tags, along with derived tags. So when we combine advanced tags with our database features, we can build some pretty complex systems that involve database interaction. So for example, we could run queries and then link tags could automatically push the return data sets to devices connected to KEPServer. We could allow devices to trigger stored procedures and then automatically receive the return data sets. And then we could also use a derived tag, say, to evaluate the state of 3 Boolean alarm tags and then trigger Data Logger to insert a new record in the database table only when all 3 Boolean tags are true. So that might be a roll-up alarm or a higher level alarm or an aggregate alarm, but that's very easy for us to do with derived tags. So first, I'm going to demonstrate 3 things. I'm going to demonstrate automatically pushing query data to a PLC. I'm going to demonstrate how a PLC can execute a stored procedure and then automatically receive the results. And then finally, I'm going to build a derived tag to build that sophisticated roll-up trigger monitoring 3 values for Boolean true. And then only then will Data Logger insert a record. So I'll go ahead and start with automatically pushing query data to a PLC. So for this, I've actually designed a little project ahead of time, just for time's sake. It's called Adding Advanced Tags. And what I have is a simulated device that's simulated just an injection molding machine. There's nothing special about this simulated device. It's a simple 16-bit device with a series of tags that I've gone ahead and created ahead of time. And then I have my ODBC client channel in a couple of different access methods. The first one that we're going to talk about now is the query batch ID assignment. So what I want to do in this example is have the PLC designed to say, hey, look, I'm PLC 1, and I need my batch ID that is assigned to me for this given point in time. So what I've done is build a simple query that selects the batch ID from my batch ID assignment table, where my PLC ID column is equal to a string called line 1. I can show you what that looks like. So there it is, my PLC line 1, 2, 3, and 4, and then my batch ID assignments. And then from there, to automatically push this data down to the PLC, I've used an advanced tag. So here's my simple link. All it does is every 1.5 seconds, it will, whatever the query results in, it'll push the resulting data down to the proper tag in the device. So as PLC line 1 is querying and running that query through the ODBC client, what's happening is that if there's any changes in the back end of the batch ID, the device is automatically updated with that batch ID change. Excellent. So I'll go ahead and demonstrate this right now. The data is going to end up, by the way, in this tag right here. So notice first I've got batch ID 1 assigned to PLC line 1. And then this is the PLC line 1. And then here are my queries and stored procedures that reference or are related to PLC line 1. So go ahead and launch Quick Client. And what you'll see, I'll go down to my simulated device and look at its collection of tags. And we can go ahead and look at that. Batch ID 1 batch ID has been assigned a value of 1. So if I go back into the database here and select a batch ID of 2, just edit the top 200 rows, add a number 2 there, and execute it. If I go back to QuickLine, I should see looks like I'm having a problem editing. There we go. So now I should see batch ID number 2 reflect the batch ID field. So if I come in and do number 3, I'll see number 3 is quickly reflected. So I'll move this back to batch ID 1. And so from there you can see that with the ODBC client automatically running a query that is related to line 1 to source the batch ID that has been assigned to line 1 from this table, I can use advanced tags to automatically update the PLC in real time when its batch ID assignment changes. So again, that's automatically pushing query data down to a PLC. The second example is I want to allow a PLC to execute a stored procedure and then automatically receive the results. So this is the second device within my ODBC client channel. It's get recipe and model. And what happens with this stored procedure is it takes a batch ID as input, and then as output, it returns a recipe ID. What is it making? What is the device supposed to be making? And then the recipe string. So in my example, the string is a series of integers that tell the PLC to take certain actions that produce the desired model. So I'll go ahead and look at my instance of QuickClient here and notice that the batch ID is number 1. And then I'm going to go up to my batch ID assignment, or sorry, my get recipe and model device object here. It's represented right here. And you can see that, lo and behold, the batch ID value of 1 is automatically reflected right there. And what's happening is that I have an advanced tag that is linking a batch ID to the stored procedure input. And it's just doing this on a timer every 1 second, so it can always be updated. It can always be updating the stored procedure so that in the PLC will get assigned that new batch ID, and then the stored procedure is ready to execute the batch ID exchange for recipe information as soon as the PLC is ready for it. So notice that, in QuickClient, if I come in here and change the batch ID to 2, we'll see a 2 reflected in the input for this batch ID, just like we see the 2 reflected in the batch ID field that is being returned from the query. So I'm going to go ahead and set this back to 1. And then the PLC, this usually is done through ladder logic within the PLC. I've created a send recipe tag. And all I'm doing is monitoring that send recipe tag and executing the stored procedure when the send recipe tag is Boolean true. So you could simply say, okay, at this point in the process, ladder logic tells this data object inside of the PLC to be set to Boolean true for a certain period of time, long enough for us to be guaranteed that we would pick it up. And again, we want to be reading this twice as fast as the data is changing. So if it was going to be held open for 3 seconds, we would want to be reading that data point every 1.5 seconds so we can make sure it doesn't change before we catch it. Anyway, I'm going to mimic the ladder logic in the PLC by turning this Boolean value on. And before I do that, I'm going to show you the advanced tag. So what I'm doing here is executing the stored procedure through this advanced tag, which is monitoring the value of send recipe in my injection molding device. And then when the tag value is not equal to 0, I am going to write the send recipe value to the execute bit, thereby executing the stored procedure. From there, these tags will automatically, the second couple of advanced tags will automatically push the output of the stored procedure down to certain tags in the PLC. And this is happening on value change. So anytime there's a new value returned from the stored procedure, we'll automatically push it to the PLC. So from there, I'll go ahead and write a value of 1. I just need to make sure I have the right tag. Send recipe. Okay. So I'll go ahead and write a value of 1 and execute it. And we should see that the recipe string and the recipe model type is returned, and it is. So now the PLC knows that it is making chair model 1, and then it should use this recipe string to produce the part. So what happens if there's another batch ID? Let me just make this number 2, right? And so I need to reset the execute bit Again, that would be done manually through ladder, but I'm playing ladder in this simulated PLC. So here we have a new batch ID. It's batch ID 2. Let's say it's the afternoon run. I'll go ahead and execute the serve procedure, and this is the PLC hitting a certain point in its ladder logic where it's ready for the recipe. Go ahead and execute that, and we should see chair model 2 and then a new recipe string returned. I could do the same thing, and in the third run at the end of the night, let's say it's recipe number 3 or batch ID number 3. And again, I'll just reset the bit, execute the serve procedure again, and I'll see chair model 3 and then a new recipe string populate the PLC. So that's stored procedures executed by a PLC that then the PLC is automatically consuming the results. So I'll jump back into the presentation. The last example, the last demonstration I wanted to provide was using the derived tags to build triggers for data logger. Let's go ahead and do that. In the simulated injection molding machine, I've got 3 alarm bits. The current state of all 3 of those alarm bits are 0, right? And what I want to do is build a simple derived tag that says, okay, when all 3 of those alarm bits are high, I then log a record to the database with the current batch ID, recipe ID, and recipe string so that I know what the machine was building when I saw those 3 alarms go true. So to do that, I'll just build a quick little derived tag that's derived alarm trigger. And all it does, this expression evaluates 3 tags, those 3 alarm tags, 1, 2, and 3, for Boolean true. And the AND operation simply means that when this is true, and this is true, and this is true, set the derived tag itself to Boolean true. So I can look at the current state of that derived tag, and it will be 0 because the state of those alarm bits are also 0. So before I demonstrate that, I want to actually build a data logger log group that will use that derived tag and log the recipe information from the PLC when those alarm bits go high. So to do that, again, I'm just going to select my DSN from my databases webinar. I'm going to add a few items into my data map. Actually, to do that, I want to browse so I can add multiple. Now I want to add batch ID, recipe ID, alarm string. I'll just add the whole kit and caboodle here. And then I'll just design a quick database table. I'm going to leave the table format as narrow. And then what I'm going to do is modify this trigger so that it triggers on condition. And the condition is going to be that the advanced tag derived alarm trigger is not equal to 0. The stop condition, and by the way, I want to log all of the items in the log group when the start condition is met. So that means that when the Boolean trigger goes high, that roll up of all 3 values goes high, I want to log all of the server items to the database immediately. And then my stop condition, which will reset the trigger, will be the same tag equal to a specific value, and that is 0. But I don't want to log the items when this condition is met because I only care about the rising edge of those alarms. I don't say let's care so much right now about those alarms going false and logging the status of the machine when it does that. So I don't need any other logging conditions because all I really want to do is log when that first condition is met. So I'll go ahead and press next, next, and finish. And just double checking everything, yeah, it looks good. All right, so I'll go ahead and apply. I've got some status messages here. I'm already connected. I've created the database table. I can go into SQL just to make sure. And there it is. I don't have any data in there yet, right? My alarm conditions are still false. Let's see what happens when I set those alarm conditions true. And what I'll do is just copy this tag and place it into this group so we can see immediately what happens. So here, I'm going to set the first alarm bit high, and then I'll set the second 2 alarm bits high as well. So you can see the derived tag is still 0, but watch when I set that last alarm bit, the derived tag should equal Boolean true. And it does. And now, let's go into the database and see if we have any records. So we do. So there's the 3 alarm bits the batch identifier, the recipe type, and then the recipe string. And then I also logged the send recipe. So there we go. You know, I only logged once when the start condition was met. So if I reset one of these triggers, the derive tag is now going to equal Boolean false. We're not going to have a new record there. It's just going to still be the same. And then from there, if I set this alarm high again, we'll see a new record inserted. There you go. There's the second record that was inserted. So now I can keep track of the stuff my PLC was doing when it errored out or when these 3 alarm bits were happening. So that's an example of using a derive tag to build a roll-up trigger and then using that trigger in order to trigger the logging of a data logger log group under certain conditions. Okay, so last poll question is, would you find value in KEP server handling some of your necessary database interactions? So I'll kick off the poll now. We'll give about a minute for this poll. Poll's been open for about 50 seconds now. We'll leave it open for another 50 seconds or so. Okay, about 85% of folks voted. Thank you very much. I'm going to go ahead and close the poll and share the results. So it looks like a lot of people would find value in KEP server handling some required database interactions. And that's great to know. Excellent. Thank you for responding. I'm going to go ahead and hide the results and then move on to the last section of the presentation, which is some complex systems that we built using the database interaction tools and advanced tags. So the first is a database system that, forgetting everything that's on the screen right now, all it does is allow a PLC to be automatically updated when new data is added to a database, or it allows the PLC to solicit new records at certain points in the PLC's process. And this is essentially combining the first 2 advanced tags examples that I went through in this demonstration. So it combines the advanced tag demonstration to automatically push query data to a PLC, which is this process right here. New records are required by a static database query. And then when the query returns something new, advanced tags automatically pushes through our solicited ControlLogix driver that written data down to the PLC. So we're noticing a new record or new data has been added to the database that is reflected in our query. And then we're automatically pushing that data to the PLC. But then number 2 is also covered. So we're allowing the same PLC to execute a stored procedure. Say if it hits a certain point in its process and it believes that it should be updated with data from a database, but it hasn't received that data yet, we have a very simple way of allowing the PLC to solicit that record. So again, all it does is set a Boolean trigger true, which we link to the execute bit of the stored procedure. We then execute the procedure, get the results, and then another group of advanced tags just pushes the results down to the PLC. So, it looks rather complicated in the design. There are a lot of buttons to click, but at the end of the day, what it's doing is very simple. When something new is produced in the database, it shares it with the PLC. When the PLC is ready for something new from the database, we've built a mechanism that will allow the PLC to solicit certain data sets that it needs. So again, we'll be recording this, and you can reference this diagram if you wanted to spend more time reading about it. For now, I'm going to move on to the second complex example. And what this allows, what this system does is allow an operator panel using an Oracle manufacturing operations control system to control a Mettler-Toledo weight scale. And then what it also allows the operator to do is log certain data at certain time to a database. So essentially what we've done is when an operator comes into his MOC panel, he'll punch buttons, she'll punch buttons, and that will insert new data in fields in a record. And then our ODBC client driver is looking at those fields, and we're saying, okay, what are the value of those fields? When we see certain values in those fields, advanced tags execute, specifically links tags execute certain commands that we've built with our Mettler-Toledo weight scale driver that tell the scale to do things like care and take a gross weight measurement, log the weight. And so what we've done is essentially link two completely disparate systems together through a database using the functionality of advanced tags as the brains or the logic to actually execute commands and tell data logger to log certain data at certain points in time. So what we've been able to do is, we can have an operator control issue inputs. That's, again, the ODBC client allows KEP server to be aware of those inputs. Our link tags link fields in the control table to command tags in the Mettler-Toledo weight scale driver. And then from there, we have a whole set of derived tags that evaluate whether the operator has asked for the scale to be reset and to confirm that the scale has been reset. And then from there, as soon as that set of derived tags is true, the operator gets confirmation that he's reset the scale by an instance of data logger logging a log reset confirmation. So we're giving the operator control panel everything that the operator would need to know that, number one, I have performed certain operations on the scale, and number two, I can guarantee that they did occur. And again, all this is done through connecting to a database table that was exposed by the Oracle DBA that is also exposed to the manufacturing operations control system that presents an operator panel at this particular packaging section of a plant. So again, if there are questions about this, I'm happy to answer those in email. You can also re-reference the webinar once it's recorded and up on our YouTube channel. All right, so we're going to answer questions in just a couple of minutes. I just wanted to wrap up real quick. The licensing requirements for everything that we discussed today, pretty straightforward. Data logger, the advanced simulator, which is part of the memory-based, which is part of the simulation suite, which also includes the memory-based driver, which will let you simulate PLCs in different sorts of devices within KEP server. We also talked about the ODBC client driver and advanced tags. So those 4 drivers were used in today's presentation. System requirements for all of this, pretty lightweight, a couple hundred megs of disk space, a couple gigahertz processor, and then at least a gig of RAM. And then there we go. That's the presentation. So at this point, I know there are a few outstanding questions. One I wanted to speak to was the fixed table method. So the fixed table method would allow KEP server to understand that fields were modified within given records. It would not allow us to be aware of new records that were added to that database table, because we're generating tags in a fixed method based on exactly the fields that exist in that database at that moment in time. If you have tables that are changing in record count, then you'd want to use one of the other 3 methods of accessing that data, a dynamic table, a query, or a SOAP procedure. All right, next set of questions. Is data logger capable of inserting records into tables using a schema other than DBO? That's a good question. I'd rather not answer that right now. I'd rather do a little bit of research and then get back to you. That's actually a question I haven't come across before. So I'll note that down and then respond to you. Thank you, Matt. That was a great question. The next is there a demo? And absolutely, all of our software is available to use for 2 hours at a time, totally for free, and you get full functionality. After 2 hours, the software will time out, and then you'll just need to restart the runtime service of KEP server, which is a simple right-click the administration tool, stop runtime, right-click administration tool, start runtime, and that resets the demo timer. How do we get a copy of the 4 plugins? You can download KEP server and choose to install them. as simple as that. Single executable holds everything within KEP-Server. Requirements for running KEP-Server on virtual machines. We're actually not aware that we're running on a virtual machine. I don't know if anybody noticed, but I'm actually running a VM right now. So for us, we don't really know that we are on a VM. All we care about is the OS. There are some licensing requirements that should be taken into account with advanced hypervisor features like automatic VM migration between ESX clusters. For those kind of environments, you want to have a conversation with us about the best way to move forward. But in general, KEP-Server runs great on VM, and a lot of our customers use it that way. Second question is a great one. I have a manufacturing vertical bundle and advanced tags. Does my license also include the ODBC client? The answer is yes. That the ODBC client is included in the manufacturing suite. What if you need to use two database loggers for redundancy? The database loggers, data logger, are not application aware, but there are methods by which you could use advanced tags and memory-based drivers to trigger a secondary instance of data logger to turn on when the primary instance of data logger fails. So I encourage you to reach out to our team, the applications engineering team, or our technical support team to talk in more detail about that. Which is faster sending information, advanced tags or LinkMaster? LinkMaster is extremely fast, but advanced tags has the benefit of being a plugin for KEP-Server. And when advanced tags needs to operate, it doesn't use OPC, it uses just thread share, essentially data sharing between threads in the main KEP-Server runtime. So there's some latency reduced because we don't have to communicate through an OPC layer from LinkMaster to KEP-Server, but it's really minimal. There's not much difference in performance between the two applications unless you're in an environment, say, that demands data traffic on the order of tens of milliseconds. And then, we would want to get as many advantages as we could in terms of performance. But in general, the two are very similar.
All right, as Sam said, thank you for participating in today's webinar. We will send you additional information on this topic by email, and we'll make a recording of this webinar available on Kepware's YouTube channel. If you have any questions that were not addressed today, please contact the Kepware representative by email or by the phone number provided on your screen. Don't forget to visit kepware.com to download a free, fully functional software demo. This concludes our webinar.
Thanks, everyone.